Okay, so let's actually look at each part separately, right? So for instance, um, if I were to just look at the base, right? What is the limit of just this base, x minus 1 over x plus 2 as x goes to infinity? Can you say? What happens as x goes to infinity here? Infinity over infinity, that's right. Right, x goes to infinity, so x minus 1 and x plus 2 both go to infinity. So I can actually use L'Hopital's rule for that particular limit. Notice this is not the same as the original limit, right? So I get 1 over 1, so I get a limit of 1. Okay. And now for the exponent x, and that's kind of trivial. As x goes to infinity, the exponent goes to infinity. I mean, that's obvious. So that means, so our original limit that we're actually dealing with actually has the very specific form 1 to the infinity, right? Because the base goes to 1 and the exponent goes to infinity. So even though you were all right for saying, oh, we have to do that ln trick for L'Hopital's rule, I just wanted to kind of make clear why we're actually doing that. I have an indeterminate exponent. Okay. So now we use logarithms and L'Hopital, right? And like a few who already said, the reason why we're using logarithms is because I want to get this into the form of a quotient. Okay. So let's let L be the original limit, right? We've seen this strategy a lot, right? Let's take the ln of both sides. So I get the ln of this whole big mess. Should be a plus 2. And then we have all seen this before, right? The whole point of the ln is it makes the exponent into a product, right? Because this exponent can now come outside of ln. So let's actually circle that. Okay. I get x ln of x minus 1 over x plus 2. Now this is a product. We know we still have to get into the form of a quotient. So what I'm going to do is this first factor x, I'm going to write it in the denominator as 1 over x, right? I still can't change this limit algebraically, but I can write it as a quotient. Just so I don't, there's a page break right there, so make sure I don't hit that page break. Okay, so up top we get ln of x minus 1 over x plus 2, and then the denominator is 1 over x, right? Notice that's algebraically the same thing as the previous line. All right. Now what happens as x goes to infinity? So this is ln of 1, right? Remember that this fraction, we already know from earlier that that has limit 1 as x goes to infinity. So I get ln of 1, which is 0, and 1 over x, 1 over infinity goes to 0. So I get 0 over 0. And so now I'm ready to do L'Hopital's rule. So it looked like when you guys asked me this question at the beginning, it looked like a lot of you had actually gotten this form this far and just kind of maybe got stuck here with the derivative, just with some algebra maybe. All right, so let's now L'Hopital's rule, we know we take the derivative of the top and bottom separately. So for 1 over x, the derivative of 1 over x is negative 1 over x squared. Okay. Now for the ln thing. First of all, I get 1 over whatever was already there. And when I do 1 over that, I actually get that fraction flipped. So the derivative of ln here is x plus 2 over x minus 1, right? The flip of that fraction. But then times chain rule tells me I also have to multiply by the derivative of the inside function. So that I can get by using quotient rule. So x plus 2 squared down below, bottom derivative top, minus top derivative bottom. Okay, and now we have to do some algebra. So let me first deal with the numerator. So up top, we actually have, what is this? X plus 2 minus x plus 1. Right? So the x's cancel out. That whole thing actually ends up just being 3. This is negative 1 over x squared. So we also see that an x plus 2, one of those factors actually cancels out. And at the same time, this negative 1 over x squared, remember now I can flip that back up as a negative x squared, right? 1 over negative 1 over x squared is negative x squared. So I can multiply the whole thing by negative x squared. Let's do that. So I get negative x squared times 1 over x minus 1, right? Because the x plus 2 has now canceled out, times 3 over x plus 2, right? Only one of the factors has canceled out here. And now this expression, I should be able to write very neatly as the fraction, let's see, negative 3x squared over, and let's actually multiply this out, x squared plus x minus 2. Okay, so lots of algebra. Any questions up until that point? Because it sounded like you guys kind of got somewhere around here, but maybe messed up algebra or derivatives or something. Nikita, you asked, how are you doing, Nikita? Do you see your mistake, or were you were getting it? Yeah, I didn't. Ah, you didn't bring the 1 over x to the minus 2 to the top. Okay, yeah. Okay, so now that you actually see that algebra, okay, so now the algebra is done, and now let's compute this limit again, right? We still have to do x going to infinity, but now what do we see? Well, they have a leading term of x squared, right? And we know that the shortcut is going to be, I just look at the leading coefficients, right? Negative 3 over 1. But let's actually make sure that I mean, you can use the shortcuts, that's fine. But let's also make sure we understand where the shortcuts come from. So those shortcuts actually come from the fact that if I divide everything by x squared, right? The leading term is x squared. So if I divide everything by x squared, I get negative 3 over 1 plus 1 over x minus 2 over x squared. And then when I do as x goes to infinity, all of those reciprocals go to 0, right? I get negative 3 over 1 plus 0 minus 0, so I get negative 3 as my answer. And then we're pretty much done, right? Just remember that you did all that work, don't mess up the very last step. So all of this actually just tells us that ln of L equals negative 3. So the original limit we wanted is e to the negative 3. Okay, questions. I see Sahana's gonna ask a question. Can we reapply L'Hopital's rule? Yes, you can also do that. So at this stage, you can also say as x goes to infinity, this is negative infinity over infinity, and you can do L'Hopital's rule twice because you'll do it once, you'll get you'll get negative infinity over infinity again, and then you can do it a second time. So L'Hopital's rule 2 more times is also perfectly fine. Any other questions? All right, cool. Yeah, that was a pretty tough problem.